Today's video reference notes, you're going to learn about, for the first time in 8th grade, the Pythagorean Theorem. So the Pythagorean Theorem is a theorem that is a mathematical law that was discovered by a mathematician named Pythagoras, and it's to find the missing side lengths of right triangles only. So the first thing you need to be able to do before we even talk about the theorem is identify the three sides of the right triangle. So right triangles are right triangle because it has this 90-degree angle. So whenever you look opposite of the 90-degree angle, it's called your hypotenuse, and that is what we refer to in the Pythagorean theorem as your C value. The two shorter sides are called your legs. So this would be your leg A, and B is also your other leg. So legs are A and B, and the opposite to 90 is your C hypotenuse. And that says it here. C is always the longest side opposite the right angle, and A and B are your two shorter sides that make up the right triangle. So in this example, I'm going to show you how to use the Pythagorean theorem, which I should have already said by now, states that when you have this right triangle, a squared plus b squared always equals c squared. So let's see how that applies to a missing hypotenuse example. So you can see here, if we label our triangle, that is going to be our C, and then 5 and 12 will be A and B. It doesn't matter, you could have made this B and this A, but those are your legs. So we always start off by writing out the Pythagorean theorem, a squared plus b squared equals c squared. So we plug in those numbers. So 5 squared plus 12 squared equals c squared. So I can square those two numbers and get 25 plus 144 equals c squared. And 25 plus 144 is 169 equals c squared. So in our last unit, we talked a lot about how to solve equations that have squares or cubes in it. Can anyone tell me what I'm going to do to both sides? That's right, square root both sides. So this will cancel out the exponent of 2, and you're going to be left with c equals square root of 169. Does anyone remember that from our list? It was in our, it's a perfect square, 13. So that tells us that the missing value of the length of this hypotenuse is 13. Let's try a missing leg example. So again, we're going to label what we know, but we start with this value, which is C, the hypotenuse. And then this is going to be, these two missing ones are A and B. A squared plus B squared equals C squared. Plug in what I know. So I don't know what A squared is. It's blank, so I'm just going to leave A squared alone. Plus B squared is 24 squared equals C squared. C is going to be 25, so I write 25 squared. So now I got to square these two numbers, and 24 squared is 576. I'm doing this in my calculator. I wouldn't expect you to know this by heart. And then this squared is 625. So now we have a situation where we want to solve for A. And so we still have a square, so at the end we're still going to square root, but we have to get rid of this 576. Does anyone know how I'm going to get rid of the 576? Subtract 576 on both sides. So when you do that, you're left with A squared equals 49. Our last step is to get rid of that square by square rooting both sides, and you're left with A equals 7. So we can now say that this missing leg is 7. So in both of these examples, it won't always be this perfect where you're left with a perfect square of 13 for this hypotenuse, and a perfect square of 49, which is 7 for this leg. a lot of times in the examples we're about to do, you'll be left with an irrational number at the end, and you'll either estimate like we've done all of the previous unit, or we'll use our calculator, and maybe your square root at the end will be 85, and you'll square root, and you'll round that to 9.2. I hope this video has been a good introduction into the Pythagorean theorem. This makes me very happy.